In order to understand biology, we first have to understand some chemistry. And so we're going to be doing really the basic chemistry that you need to know in order to understand biology. And so it's a huge topic, and we're going to be condensing it down to as little as you need to know. So I always say that if it feels like we're not getting the full story, that's because I'm trying to keep it as simple as you need for this course. So we'll start out by talking about atoms. And atoms are, the definition is the smallest functional unit of matter. And so in a nutshell, it's basically the smallest unit of everything that is in the universe. And you can take anything that is in the universe and break it down into its smallest components, and that would be atoms. And atoms are kind of like the cell in the sense that you can break something all the way down to atoms and still have it retain the properties of that particular atom. So for example, you could break down hydrogen gas to just hydrogen atoms, the smallest level, and it still behave like hydrogen. You also probably think of atoms sort of interchangeably with elements. So like silver's an element, gold's an element, oxygen's an element. These are all examples of elements. I can take gold and break it down into gold atoms. So that's kind of the relationship there. So atoms are made up of three different types of subatomic particles. That means subatomic means smaller than the atom. And again, there's three types of particles that make up the atom. Protons, neutrons, and electrons. A proton is a positively charged particle. So think P for positive. It's located in the center of the atom, and that center of the atom is called the nucleus. Don't confuse this with the nucleus of a cell. It's the nucleus of an atom. So basically the word nucleus just means center of. The other subatomic particle is a neutron for neutral charge. It's also found in the nucleus of the atom, sort of mixed in or clumped together with the protons. And the final subatomic particle is the electron. The electron has a negative charge, and it's not in the nucleus. It's found in areas called orbitals outside or surrounding the nucleus. The entire atom typically has no charge, so it's neither positive nor negative, even though we have positive and negatively charged particles inside of it. So why would that be? Well, in a neutral atom, you always have equal numbers of positive protons and negative electrons. And so, for example, let me get my pen up here, I might have 14 protons, which are 14 positive charges, but if I have 14 electrons, that's minus 14, that's going to get me to a charge of 0. So as long as I have the same number of protons and electrons, I'll have a neutral atom. So I mentioned earlier that protons and neutrons are in the nucleus, and they are clumped together here in the nucleus. And electrons are flying around in the space outside of the nucleus. And in the simplified model of the atom, the electrons are thought of almost as sort of circling the nucleus in the space outside of it. In reality, it's a little more complicated, of course. And we're not going to spend a lot of time on this, but just to give you an idea, if this is my, so again, let me get my pen up here. If this is my nucleus here, and maybe I've got some neutrons clumped in there, so some protons, some neutrons clumped together in my nucleus. I have one electron. The electron is my pen, okay? Electrons are going to fly around, and I can't do this super fast with this, but fly around really, really fast, occasionally fly out of that area, over to another area, back to the original area, out this way. This is all the same electron flying around really, really fast. Okay, that area, so let me circle it here, this area here is the orbitals. So it's the area where electrons tend to hang out. They don't always have to be there, so notice my electron came flying out of there, but they tend to be located in that area. We're going to focus more on energy shells. So orbitals will fill energy shells, so there's multiple orbitals in an energy shell. And we're going to focus on these energy levels or energy shells because that's going to tell us a little bit about bonding, and we'll talk about that a little bit later. So again, we're going to stick to these energy shells and with this simplified model of the atom. So if we look at an example of this, an atom of nitrogen has 7 protons. That must be balanced by 7 electrons to get a neutral charge. The energy shells fill in a predictable way. So the first energy shell always fills with 2 electrons. Every energy shell after that, so the second, the third, the fourth energy shell, they will fill with 8 electrons. So basically the electrons will pile in first into the first shell, 2 into the first shell, as many that are left into the second shell, up to 8, and then if there's more than that, then it has to go into the third shell, up till 8, and so on, filling the energy shells. The outermost shell is really special. It's called the valence shell, and any electrons that are in there are the valence electrons. So it might be the 5th shell is the last shell. It depends on the atom. So that valence shell is special. So this is an image of the simplified model of nitrogen, so the one we were just talking about. So again, nitrogen has 7 protons in here. They're clumped together with the neutrons in the nucleus. So notice they're clumped together in the center. And then the electrons are in these energy shells. So 2 electrons fit into the first one, and that fills it. So the remaining 5 electrons have to go into the outermost shell or the valence shell. So there's 1, 2, 3, 4, 5 electrons in the valence shell. Now this valence shell is not full. There's 5 electrons here. It could fit as many as 8 electrons. And so how many electrons are in the valence shell, or how far away from being full the valence shell is going to have really important consequences for behavior. So nitrogen, because it does not have a full valence shell, it has these 3 electrons that it still needs to make it full, will tend to interact with other atoms in order to make a full valence shell. So that's a little bit of a preview for bonding that we're going to talk about later on in this chapter. So that's the atom, and we'll stop here for now.